Might actually.
I wish I was there.
Thanks, Dad.
My dad wanted to name me for it.
Really? Jackie Jackson. Is it just Jackie Jackson?
All right, so you want to just take a look at the B over A, and this is similar to one we did from yesterday. You got that fraction in front. Is 2 a possible 0?
Yes.
Yeah, as long as it occurs on our list. 2 is a possible 0. Is B, or excuse me, is negative 1/2 a possible 0?
Yes.
Yes. Is negative 1/6? 2/3? Negative 6. Yep. So I don't know whether they are zeros. It's immaterial. It's just could they be tested, or should they be tested using synthetic division? And yes, because they fall under that B over A situation. That's all we're checking. Possible zeros. Now on your work from yesterday, a lot of you got to 3. Did anybody get finished with 3? Carter, you got it?
I think so.
You think so? Well, let me just give you those answers. Most of you got through 2, okay? And 3, you had a lot of options, right? And so you were just testing. One thing we're going to do today is just try and give you a couple ways to maybe simplify what you choose. There's never a way that you can just narrow it all the way down to something that works. There's still always going to be an element of guess and check. You just pick a number, you plug it in, you see if it works. That's just always going to be part of it. On number 2, if you noticed, you had a double root. So you either had to get a root by plugging in a fraction, or you could have plugged in -2 twice. We talked about that. There are going to be situations where you plug in a value and then it will work again. So don't assume just because it worked one time, it will not work again. So A and B both had a double root. For 3, these are the 3 roots that you had to find using synthetic division. And then once you got that, you were left with a quadratic that didn't factor, and you had to use a quadratic formula. So those 3, if you don't have them, write them down so that at some point you can go back, do the synthetic division, and then simplify it. So -2 will be a root, -3/2 is a root, and 1 is a root. And then I think, what does it come down to? X squared. What'd you get, Carter? Do you know what it comes down to, that quadratic that didn't factor?
Which one?
For 3.
Oh, I got it wrong.
Oh,
It's right.
how'd you get it wrong?
Oh, you had it? Yeah.
Okay. All right, now, I want to just point something out. Now, initially, where did you put it?
Probably the bottom right.
Okay, so when you get your roots of -3/2, of -2, and 1, all right, this is how it initially looks. Now, one thing I did say, hold on, I didn't write that down correctly. You don't want to have, you can't have a fraction in your final answer. Okay, so remember we talked about what we do for this? This is going to happen. What's going to be true about that last piece? There's going to have a GCF of 2. You use that to multiply into this one with the fraction, and what will that one become? That'll become 2x plus 3. So you're going to end up with x plus 2. When I factor that 2 out, you don't want to multiply it into either of these other 2 because they already have whole numbers. That becomes 2x plus 3, x minus 1, and then this will become x squared minus 6x plus 7. Okay, that'll be the case. And then you use quadratic form that you get the 3 plus or minus radical 2 there. It's all that is just an effort and persistence. Okay, you just got to be persistent, keep trying until you get it. A couple key things you got to watch is if you make a mistake on a root, if you test a 1 and you make an arithmetic mistake and it doesn't come out to 0, then you're, especially on this problem, you're going to be in big trouble because you're not going to go back to think about doing it again. So you really got to watch on that. All right, so that's number 3. I want to look at 4, 5, and 6. Okay, I know I said to look at 4 if you got a chance, but let's go through those. You're going to need to know how to do those as well. We're going backwards. A couple key words here. Polynomial function of least possible degree. That means there's no double roots. Okay, you don't need to worry about that. Integer coefficients. No fractions, no decimals. Okay, we're going to make everything a whole number. No square roots. All right, these are my roots. Well, if -3 is a root, what's the factor? So -3 would work. What's the factor? X plus 3. So that would be x plus 3. If 1's a root, x minus 1's a factor. If 4 is a root, x minus 4 is a factor. Now, we would need to multiply that all together, but I'm not going to go through that here. You can do that. We'll do the next one like that. But that would be the case. You'd multiply those together, get your answer. What degree would it be? Third. Okay. All right, let's take a look at 5. Now, this one does have fractions. What about -2/5? If that's the root, what's the factor? What's that? I'm hearing it's 5x plus 2. Okay, you're all right. And if you do just like totally blank on this, here's what you can do. This says x equals -2/5. You can start with that. And we're going to set it equal to 0. Well, I'm going to multiply both sides by 5. I get 5x equals -2. I'm going to add 2 to the other side. 5x plus 2 equals 0. I mean, if you just want to double check. 1/4 will give us 4x minus 1. And 5/3 would give me 3x minus 5. For this problem, I will have you multiply it out. Okay, so you're just going to start, you're going to FOIL 2 of them together. And so I get 20x squared minus 5x plus 8x minus 2. And now that's going to end up being a trinomial. I'm just going to shift that 3x minus 5 out in front. And then I'm going to simplify that to 20x squared plus 3x minus 2. And now I'm just going to multiply. And when we do that, you take your 3x times all 3. And you take your -5 times all 3. And let's see what we get. 60x cubed plus 9x squared minus 6x minus 100x squared minus 15x plus 10. And so I get f of x equals minus 91x squared minus 21x plus 10. So just multiply that all together. If you would solve that by synthetic division, you'd end up with the -2/5, the 1/4, and the 5/3, which that would be a tough one to come up with to do that. All right, the last one, 6. All right, square roots. It says you have to have integer coefficients, and in the end, we will. All right, one thing we talked about, not yesterday, but the day before, if, and it's not, they don't give it to us, but they're assuming you know. If 3 plus square root of 5 is an answer, what else is an answer? 3 minus square root of 5 has to be. So even if they don't give it to you, they say these are roots, they're assuming you're going to fill in that blank. So that means that x equals 2, 3 plus square root of 5, 3 minus square root of 5. All right, now solving that, f of x equals, all right, if 2 is a root, x minus 2 is a factor. All right, you always subtract. So we got to subtract those two. And it's going to be x minus the quantity, 3 plus square root of 5. And then x minus the quantity, 3 minus square root of 5. All right, to kind of multiply that together, what's your first instinct? First instinct. Alex, first instinct.
I'll multiply or boil the x minus 2 and the one next to it.
Oh, that might, I don't.
Or would it be the everything but the x minus 2?
Yeah, I would start here. And I'm just trying to think. I don't think I've ever tried that. And I'm even trying to think if I could. It's just going to be messy. It's going to be messy. Multiplying those two. Long story short, start with those two. Okay, now there's two different ways you can do it. I'm going to show you both ways. Doesn't matter which way you do it. We'll save the x minus 2 for the end. All right, first way. They're going to start. The start is going to be the same. Just distribute your minus sign. And so you can make it x minus 3 minus square root of 5, x minus 3 plus square root of 5. And then we're going to multiply it like it's two trinomials. Take your x times all three of them, take your negative 3 times all three of them, and take your negative 5 times all three of them. I mean, there's nothing else you can do. So we're going to just go through that whole procedure. And let's see what we get. X squared minus 3x plus, all right, x times square root of 5. What's the only way you can write it? X squared root of 5. Remember, you cannot multiply a number on the outside by a number on the inside. Negative 3 times x is minus 3x. Negative 3 times negative 3 is plus 9. Negative 3 times square root of 5 is minus 3 square root of 5. Minus x square root of 5 plus 3 square root of 5. And then lastly, negative square root of 5 times positive square root of 5 is minus 5. All right, combine all your like terms, simplify that. Now, if you've done everything right, what happens to everything with a radical 5? Cancels. Okay, so if you do everything right, that's what should happen. So you got x square root of 5 and negative x square root of 5. I actually wrote it as a 3. Minus 3 square root of 5 plus 3 square root of 5. So when we're done with that whole thing, I get x squared minus 6x plus 4. Well, what do I still have from up above, though? What's the other factor we haven't used yet? X minus 2? All right, so we got x minus 2 times x squared minus 6x plus 4. All right, I'm going to leave that. I'm not going to go through that because you can do that. You already know how to do that. It's just going through the procedure. All right, let me show you the second way. All right, I am going to kind of start the same way. I'm going to write this as x minus 3 minus square root of 5, and then x minus 3 plus square root of 5. Okay, for this. And now I'm going to, they both have this x minus 3 is their first two terms. So I'm going to write this, and we'll put those in parentheses. Now think about this. The reason I did this is I want you to think of this as a minus b times A plus B. Where my A is just what? My A is the group x minus 3. It's the same thing. So I'm subtracting square root of 5. I'm adding square root of 5. Well, what do you get when you multiply A squared minus B, or A minus B times A plus B? Just the difference of squares. And so when I'm done and I multiply, you end up with A squared minus B squared, right? So apply that to this case here. What's that going to look like? Well, my A is just x minus 3, so A squared is going to be what? X minus 3 squared minus square root of 5 times square root of 5, which is what? 5. Now you still got a FOIL there. And so that gives me x squared minus 6x plus 9 minus 5. I still get the same thing. And so I'm still going to end up with f of x equals x minus 2 times x squared minus 6x plus 4. Some people are more comfortable over here just multiplying that whole thing out. I think this is a little bit quicker, but some people, like I said, aren't as comfortable. If you understand that's really a difference of squares, you're multiplying those two together. That'll be that quantity squared. You still got to FOIL it, but we still end up with the same thing. Okay, I don't care which way you do it, all right, but this will come up. So just make sure you see that. All right, now the last thing of this section, you don't need to turn in your book, but there's a couple little tricks to help you narrow the search for rational zeros, so you're just not randomly guessing. I got some, I guess they're guided notes. I got some notes here. Let me hand those out on this. All right, here's the reality of the situation. If you're given a problem, you're probably just going to just find numbers and plug them in and do synthetic division. All right. You're probably not going to use these, but I'm going to show them to you anyway. They might come in handy for a person or two. You do need to know Descartes' rule of signs and use it on a quiz or test. Okay, I'll show you how that works. I'm going to give you the rules for upper and lower bounds. You won't be tested on it. Okay, it's just a fun fact. Descartes' rule of signs. Let f of x be a polynomial function with real coefficients and with terms written in descending order. So you got to put them in order. Okay. The number of positive zeros of f is either equal to the number of variations of sign or less than that number by an even integer. I know that makes no sense right now. Okay, we'll go through the example and it'll clear some things up. The number of negative zeros of f is either equal to the number of variations of sign of f of negative x or less than that by an even integer. All right, so what they're saying is in the end, like when you get your answers, this would be 3 positive zeros, this would be 1 negative. If you knew ahead of time that there were going to be more positive than negative numbers, you would test the positive numbers first. If you knew there were going to be more negative answers than positive answers, you would test the negative numbers first. That's really all it's saying. It's not giving you what the numbers are. It's just saying, hey, you're probably going to get 3 positive answers. Why don't you start there? Okay. Now, here's how it works. The variations of sign. This is a problem right on your sheet. Same one. All you're doing is watching, does it go from positive to negative, or does it stay negative between terms? So if this is a positive term, you would consider that a negative term. That would be one variation of sign. It stays negative to negative. That doesn't count. It goes from negative to positive. That is 2. Positive to negative, 3. Now, let me go backwards. Whatever the variations of signs, it said it'll be that number or less than that by an even integer. So if you would have 5 changes of sign, then you would always subtract 2 from that. So then it would be 5 or 3 or 1. You go all the way down to 0, positive or negative zeros. So here's the thing. We don't know whether it's 5 or 3 or even 1, but it's going to be one of those. If it was 4, it would be 4 or 2 or 0. Okay, for that. So for this one here, they say the number of positive zeros is either 3 or 1. Okay, so it has 3 or 1 positive zeros. Now, Descartes must have had a lot of time on his hands and have no idea how he came up with this, but he did. So he says, all right, you got 3 or 1. Now, how do you check for the negative zeros? Now, how many total are there? It's x to the 5th. There has to be 5, right, at most. Okay, so 3 of them are positive or 1. For the negatives, you have to do f of negative x. That should say f of negative x. And that's going to change your equation a little bit. All this is going to do is change some of your signs. What are the only terms whose signs will actually change? It has to have what type of power? It has to have an odd power. The even power, remember, a negative number to an even power will stay positive. So the negative x to the 5th becomes a negative. Negative 3, negative x to the cubed will become a plus. This will stay a minus. This goes to a negative. That's a negative. So I only have 1, 2. So the number of negative zeros is either 2 or 0. So you have 2 or 0 negative zeros. All right, it's not overwhelmingly convincing of which direction you should head. I mean, it might give you a little bit of a guide. So since I could have 3 positive zeros, I'd probably start with the positive numbers. Quite honestly, you're just going to probably just pick the numbers you usually start with and substitute them in. You do need to know this. It does come up. Now, the next one's more of a fun fact. We talk about an upper bound or a lower bound. An upper bound would be a situation. Let's say you plug a number in, say the number 3. And this certain scenario comes up, and it's an upper bound. Well, it means you're not going to try anything above it. So this is a little bit useful. I'm not going to try 4 or 5 or anything above that, so it's going to narrow my search. That'll just come up naturally when you're substituting in a number. So for this one here, here's your 2 cases. K is the number you're using synthetic division on. When you do synthetic division, if the last row, if each number is either 0 or positive, then K is an upper bound. If you're doing a negative number in synthetic division, if your last row alternates in signs, it's a lower bound. So here's an example. All right, here's your function. Here are the possible zeros. Let's say you plug in 3. All of these are positive. It means it's a root, but also since they're all positive, I know it's an upper bound. I'm not going to bother to try 6, okay, because I know it won't work. I'd stick with 2 or 1 or the negatives. So 3 is an upper bound. So it's going to just kind of happen naturally. A lower bound is when you plug in a negative number and it alternates in signs. Now, it says a little bit above there, 0 can be a positive or negative. It can work either way. So negative 2 is a lower bound. You wouldn't try anything below negative 2. All right, so those are just 2 little facts that may play a role. All right, I just want to do one Descartes' rule of signs together to make sure this makes sense. Just throw it on the back, it's fine. All right, copy down that function. right, for the positive zeros, you just look at the number of times the sign changes. Okay, and then whatever that is, you always subtract 2 until you get down to 0. Okay, so that tells you how many. Well, in this case here, how many times does it change its sign? Once. That's it. Okay, 1. That means, all right, you cannot subtract 2 from that and get a positive number. So that means that there is one positive 0. Okay, one positive 0. To test for the negatives, you have to look at f of negative x, which is 5 negative x to the 4th plus 7 times negative x cubed minus negative x squared minus 9 times negative x minus 15. Now, if you're thinking about your rules with negatives and powers, the only thing that should change to the opposite side is an odd power. When you take negative x to the 4th power, it's going to come back as a positive. So that's 5x to the 4th. This will become minus 7x cubed. This will stay negative, x squared. This becomes positive 9x minus 15. All right, how many sign changes does this one have? It has 3, doesn't it? 5 to negative 7 is 1. Stays negative, but negative x squared to 9x is 2. 9 to negative 15 is 3. So what do we say for the number of zeros? It is 3,
3 or 1.
3 or 1. So the number of negative zeros is 3 or 1. So we will have 3 or 1 negative zeros. So I would start with a negative number. That's all it tells you. Okay, so all right, I'm going to start with a negative number. Hopefully I got a better chance of getting a negative number than a positive number. Okay, for that. So that's all Descartes' rule of signs. You do need to know how to use it. You do need to know how to solve a problem with it. The upper and lower bounds, fun facts. Maybe they'll come up when you plug in a number. If they do, you get all positive numbers in the bottom row. You say, all right, I'm not going to even bother to try. It doesn't have to be a root either. I'm not even going to bother to try anything above that.